Good morning. Today we are going to be taking notes on the Pythagorean theorem. So Pythagorean theorem. And the Pythagorean theorem deals with what we were just doing on the Desmos. So what this theorem is, what this theorem says is it is used to find sides of a right triangle. So just like we saw, we're moving that around, we can only use this with the right triangle. And the formula that comes with this is a squared plus b squared equals c squared. And what that means is you have a triangle, and it's a right triangle, and you have three parts. You have an A, a B, and a C. And the way you can label them is by knowing these two things. So the first thing you need to know are the legs. And the legs are A and B. And they can be used interchangeably. It's just the short leg and the long leg. And you can find these because they're connected to the right angle. So right here, you can see B is connected to that angle, and A is also connected to that angle. So that's how you find the legs. So the last part, the C, is called the hypotenuse. And the hypotenuse, again, is your C value. And you can find it because it's not connected to the right angle. And I like to think I find it by seeing the right angle points at it. So if I go to my thing, if I make the right angle an arrow, it's pointing at my hypotenuse. So it's pointing at my C value. I can also go like this and cover up my right angle, and whatever I'm not touching is my C value. So there's a couple ways to find your C value. So what does this all mean? Why do I care? Well, let's do an example. So say we have a right angle, a triangle, that looks like this. And we know that this side is 3 and this side is 4. But we want to know this side here. So I can fill it in here. So my A and my B are going to be 3 and 4. So I'm just going to say my A is 3, my B is 4, because they're the ones that are connected to the right angle. And my right angle is pointing at X. And now I'm just going to plug them into the formula. So A squared, I have 3 squared plus B squared, so plus 4 squared, equals C squared. So it equals X squared. Now I solve. So 3 squared is 9, 4 squared is 16. Then I combine 9 plus 16 is 25, is X squared. Well, I want to get my X alone. So I have to take the square root of both sides. So the square root is the opposite of the squared. And it's thinking what times what equals this number. So if I put that in my calculator, it'll get me 5 equals X. So my hypotenuse here is 5. Say we're looking for something else. So for our next example, say we have a right triangle, looks like this. Notice it doesn't really matter what it looks like as long as it has that right angle. Say I have this side and this side, and I'm looking for this side here. Again, I find my A, B, and C. So my A, I'm going to look for one of the sides. Okay, A can be 8. B, I want to look for the other side that's attached by this right angle, and that's my question mark. So I don't actually know my B value. So I'm just going to leave it as b, which means I'm going to see what my hypotenuse points at, and that's my c, which is 10. And I plug it into that equation and I solve again. So the Pythagorean theorem is a lot of just plugging in and solving. So I have 8 squared plus b squared equals 10 squared just by plugging in. So I have 64 plus b squared equals 100. In our last equation, we could just add them because they're on the same side of the equal sign. This one isn't, so we have to move that 64 to the other side. So I'm going to subtract each side by 64. So I have b squared equals 36. Again, to get rid of the squared, you take the square root. So here I get b equals 6. Just note on these two problems, I gave you examples where there was not a decimal place, but you can get decimal places. As always, do not be afraid if you get a decimal place, just make sure to check your work. So we're going to do some practice problems with this. Let's go.